Hey everybody, welcome to section 2.3. We're going to be talking about Venn diagrams and set operations today. We're going to stay with just 2 circles in the Venn diagram, and then in section 2.4 we'll take it up to 3 circles. Okay, so Venn diagram is just a way of organizing relationships and showing how they interact with each other. It was named after a man named John Venn, and he used in his text in symbolic logic. Okay, so in general, when you start drawing a Venn diagram, you're going to start with a big rectangle and the big or square. The big rectangle represents the universal set. Okay, so for example, if I talked about actors, my universal set would be all actors. Okay, then you can go in and you can categorize your actors. And every time you come up with a category, you're going to include a circle. So we could say circle A represents male actors. Notice that it is included in the universal set. Sometimes you'll have more than one category, okay? So if I used my same example, I could have the blue circle be male actors and the red circle be female actors. And notice that they are disjoint. We don't have actors in both categories. And so anytime a set is disjoint, the circles will not overlap. But sometimes categories will be shared, and if categories are shared, then your circles can overlap with each other if you want. Okay. This diagram where you have the circle inside of another circle represents a proper subset. So remember, in order to be a proper subset, all of the elements in set A have to be contained in set B, but A and B are not equal. So notice that subset A is a little bit smaller than B. So that's an example of a proper subset. If 2 sets are equal and they have the exact same elements in each set, then the circles would completely overlap each other and you wouldn't be able to tell where one starts and one stops. So if you look at this picture, there are 2 circles there, but because A and B have exactly the same elements, they have exactly the same circle. Usually when you look at a Venn diagram though, you're going to see 2, 3 or more circles, and the circles will overlap. The overlapping area that's between the 2 circles represents the items that they have in common. Anything that is in just circle A and not circle B represents people that are in the set A but not common with set B. Okay, and we'll look at a couple examples so that makes more sense. So when you look at that, any of their common elements are going to go in the overlapping area, which is group 2. Characteristics that are just in set A and not in set B are going to go into region 1. Characteristics that are only B and not set A are going to go into region 3. And you also have region 4, which is on the outside. Okay, so that would be elements that are in the universal set but don't have a category that would put them in circle A or circle B. A new notation that they're going to use in this section is the complement notation. The complement notation looks like a little apostrophe, so it'll give your set name and it'll put a little apostrophe next to it. And the way that you read that often is you'll say elements that are not in A. When I was in school, the teacher used to simply say A not was how they would read that. Okay, so if you ever see a complement, it's essentially the opposite of what the category is described. Okay, so for example, if our universal set was actors, let's say that category A is human actors. So then category A not would go on the outside, and those would be beings that are actors but that are not human. So you could have like your famous dogs and cats that appear in movies, things like that. Okay, so what we're going to do with most of the time is we're going to work with numbers. Okay, so let's look at this first example. Our universal set are the numbers 1 through 8. Our set A are the numbers 1, 3, and 4. Okay, so the first thing I would like you to do is I would like you to find A, and then I want you to show how it's related to U, and I want to be able to see U, A, and A not all in the picture. Okay, so if you are going to do this with a Venn diagram, then what you would do is you would draw your square, which represents U. okay? And then you would put your circle in there for A, and usually they will label that A, okay? Put your elements that are in A. The elements that are in A are 1, 3, and 4, so that you could stick those in the circle. Now, anything that did not appear in A is going to go in the outside of the circle, but inside of the square. Okay, so 1 appeared, and 3 appeared, and 4 appeared. So that means the numbers 2, 5, 6, 7, and 8 are in the universal set, but are not in A. Those elements would be considered A naught. Okay, so if they asked you to list what A naught was, you would list 2, 5, 6, 7, 8. So the overlapping area that you get between two sets when you do put two sets in the universal set is called the intersection. The intersection gets a special symbol. It looks like an N, but no tails or anything on that. So the way you would read that is you read that A and B, or you could say A intersection B. And so this is items that are common to both sets. So a really bad example that I'll use often is if you go and you order fajitas, okay, at a restaurant. Some people order steak fajitas, and some people order chicken fajitas, and some people want a little bit of both, so they would go for the combo plate, which would be in the middle, which would be both steak and chicken, if that makes any sense. Okay, so let's go back to another example. This time our universal set is the numbers 1 through 10. Set A is the numbers 1, 2, 3, 8. Set B is 1, 3, 6, 7, 8. And set C is the empty set. It has no elements in it. Okay, so I would like for you to represent A intersection B. Okay, so if you were going to do this, you could do it a couple of ways. You could do it with a Venn diagram if you want. But essentially, all you are looking for is the elements that are in A that are also in B. What elements do they have in common? So if you notice, they both have the number 1, they both have the number 3, and they both have the number 8. So if I asked you for A intersection B, you would list the set 1, 3, 8. The intersection is the common items that they both have. Okay, they could change the question a little. So I'm going to give you the same set of numbers, but this time I want you to give me A intersection C. Well, set A are the numbers 1, 2, 3, and 8. Set C is empty. So what do A and C have in common? Well, nothing. Nothing in set A appears in set C. So their intersection is the empty set. They have nothing in common. Okay, let's make it a little more difficult. Okay, this time same set of numbers, I would like you to find the intersection between A naught and B. Okay, so what I would recommend you do before you get going is I would figure out what the set A naught is. Okay, so remember A naught is going to be all the numbers in the universal set that do not appear in A. So since A includes 1, you cannot. A includes 2. So you cannot. A includes 3, so you cannot. A includes 8, so you cannot. So A naught would be 4, 5, 6, 7, 9, 10. You want this to intersect with B. Okay, well, B is the numbers 1, 3, 6, 7, 8. So what do A naught and B have in common? Okay, well, 4 appears in A naught, but not in B. 5 appears in A naught, but not in B. Okay, 6 is in A naught and also in B. 7 is in A naught and also in B. That's the only thing they have in common. So the intersection between A naught and B is the set 6, 7. Okay, let's try one more. Last one. Find the intersection between A and B, figure out what that answer is, and then find the complement of that. So notice you have to do your order of operations. You have to do what's inside of the parentheses first, get that result, After you get that result, then you're going to find the complement. Okay, so let's first find the intersection of A and B. Okay, so remember, this is what A and B have in common. So A and B have the numbers 1, 3, and 8 in common. Okay, so once we know what the intersection is, now we want to find the complement of the intersection. So these are the numbers that are in the universal set that do not happen to be 1, 3, or 8. So that would be the numbers 2, 4, 5, 6, 7, 9, and 10. So you have calculated the intersection of A and B and then found the complement. Okay, the other word that they're going to use besides intersection is they're going to use the word union. Now notice that the union symbol looks like a little U, no tails or anything like that. Okay, so for using our fajita example, let's say that I go to dinner and I go, I want steak or chicken fajitas. I don't care what I get. If I got the steak fajitas, I would be happy. If I got the chicken fajitas, I would be happy. And if I got the combo fajitas, I would still be happy. In any case, I would have experienced steak or chicken fajitas. So when you use the word or in math, it can be part of one set or the other set or both sets. So it really includes anything that lands in any of the sets, okay? So let's see that in action. So we use the universal set is 1 through 10. Your A is 1, 2, 4, 6. B is 1, 3, 6, 7, 9. And C is and C is the empty set. I would like for you to calculate A union B. So this means tell me all of the numbers that land in A or in B. And it is okay if it happens to land in both sets. So for example, the number 1 is in both sets. The number 2 is in A. The number 3 is in B. The number 4 is in A. The number 6 is in both. The number 7 is in B. And the number 9 is in B. So if you just jot down all the numbers that appear in both of those sets, you will have the union. Now, if you notice, I did not write the numbers twice. So like the number 6 appeared in A and B. I did not write it 2 times. Just write it the 1 time. All right, let's try something similar. Same set of numbers, but this time I would like you to tell me what appears in A or C. Okay, now remember, C is empty. Okay, so if you were going to list the elements that appear in C, you would have nothing to list because there's no elements in C. So all you're going to be able to list here is the elements of A. So if I want elements of A or C, I would list the elements of A and the elements of C. Since C has no elements, I would end up with just set A. Sometimes the empty set can be a little confusing for people. Let's try another one. So if you look at this one, this says it would like for you to find the complement of A, and then after you have that, find the complement of A or B, union B. Okay, so before we start, let's find the complement of A first, because that'll make life easier. So remember, when you do that, you go to your universal set, and any number that appears in A, you have to knock out of the universal set. So we have to take out the 1, we have to take out the 2, we have to take out the 4, and we have to take out the 6. So the complement of A would be 3, 5, 7, 8, 9, 10. Set B is 1, 3, 6, 7, 9. So I want the union of A naught and B. So all I have to do is list all the numbers that appear in set B and all the numbers that appear in in set A naught, and I would just list them once. So for example, the number 1 is in B. The number 3 is in both. The number 5 is in A naught. 6 is in B. 7 is in both, 8 is in A naught, 9 is in both, and 10 is in A naught. And I have represented all of the numbers from A naught union B. Okay, just to make sure we got it, we'll try one more. Okay, this time I want you to do A union B, and then after you calculate that, I want you to find the complement. So the quantity A union B naught. Okay, so A union B, I believe we already did in step 1, but just in case, we'll do it again. Okay, so A union B will have 1, 2, 3, 4, 6, 7, 9. Okay, now that's just A union B. Now you want A union B complement. Okay, so go to your universal set. Anything that appears in the universal set that does not appear in A naught, you can use. So A union B has the number 1, it has the number 2, 3, 4, 6, 7, and 9. So if I knock all those out, that is going to leave me with the numbers 5, 8, and 10. So A union B naught would be 5, 8, and 10. And that would be your final answer. Okay, so this slide just generalizes the meaning of and or. So if they ever use the word and, assume that it means intersection. And so you can use your little intersection symbol, which looks like the N. Okay, and so remember, all that means is in order to be part of the intersection, the number has to be both an element in A and an element of B. If they use the word or, assume that means union, and you can use your union symbol, which looks like the U. And if that means you're in union, then any element that is in A or that is in B can be included in your set. Often they'll ask you to find the number of elements. Okay, well, the trickiest one is the number of elements that's in the union, because you have to be careful, because some people just take the number of elements in A and the number of elements in B and they add them together. Well, that doesn't work if the sets overlap, okay? So say there's like 10 elements in A and there's 10 elements in B, you can't just say that there's 20 elements. Because some of the elements overlap, you might have counted some of them twice, okay? So if you find the number of elements in the union, there's a little formula that you have to use. You first have to take the number of elements in set A, the number of elements that are in set B, and then you have to subtract the number of elements that are in both sets, okay? So what that does is it finds the number of elements of the first category plus the number of elements in the second category, and then you have to deduct what they have in common because you would have counted that twice, once for A and once for B. So example, let's check this one out. The results of a survey of visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both Spanish and French. How many people speak Spanish or French? Okay, so you need to take the number of Spanish speakers plus the number of French speakers and deduct the both category, the people that speak both languages. Okay, well, 25 spoke Spanish, 14 spoke French, and 4 spoke both. So you would have to make that deduction. And you can just use your calculator to do that if you want to. I think your final answer will come out to be a 35 if you type that in your calculator. So there's actually 35 people that you surveyed. Okay, so just be careful. Don't count the both category 2 times. Just count it once. You can also do subtraction of sets. They call that the difference of 2 sets. It looks just like A minus B. All that means is you want the people that are in category A, but you want to deduct out anybody that could also be included in category B. So if you deduct out category B, you're going to end up with just the people that have characteristic A and not both. So if you want to write that in set builder notation, you would say that the element must be part of set A, but it cannot be part of set B. That's how you would say that. All right, so let's see an example of that. Okay, so I want you to find the difference between A and B. The universal set is A, B, C, D, E, F, G, H, I, J, K. Set A is B, D, E, F, G, H, and set B is A, B, D, H, I. Okay, so what I want you to do is I want you to look at set A, and I want you to take away any one of those elements that appears in set B. Okay, so if you notice, set B has the first element is A. All right, well, that doesn't appear in set A, so we're good there. Set B also has the letter B. Okay, that does appear in A, so we need to take that out. Set D appears in both B and A. We need to take that out. And set H appears in both B and A. We need to take that out. So A, the difference of A and B would be the elements E, F, G. And you have just calculated the difference of two sets. Okay. We can try that again. We can make it a little more complicated if you want. Okay, so same sets. This time I want you to do A, take away C. Okay, so notice that C has the element B. We got to take that away. Notice that C has the element E. We need to take that away. And notice that C has the element G. We need to take that away. So if we took all those away, set A would be left with D, F, and H. So you have just found A, take away C. Okay. You can make it more complex if you want. We could do A naught, take away B. If you're going to do that, I would first find A naught. Okay, so remember, A naught are all the elements in the universal set that are not included in set A. So we need to take out the B, the D, the E, the F, the G, and the H. So that would mean that set A naught includes A, C, I, J, and K. Okay, so this is the set we're working with, A, C, I, J, K. We want that set take away B. So B has an A in it, so that has to come out. It has a B, but we don't have a B in our set. It has a D, we don't have a D in our set. It has an H, we don't have an H in our set. It has an I, so we got to take away our I. So A naught take away B would be C, J, K. All right, last one with this example. Let's say that we're going to do A, take away C naught. So again, before I would do this, I would figure out what C naught is. Okay, so C naught is going to be all the letters in the universal set that are not included in set C. So we are going to have to remove the B, the E, and the G. Okay, so C naught would have A, C, D, F, H, I, J, K. Because that's what's left up here. Okay, now what we want to do is we want to use set A, but we want to take away anything that appears in set C naught. So C naught has an A, C, and a D, so we'll have to eliminate that D. It has an F, H, I, so we'll have to eliminate the F and the H, and a J, K. So A, take away C naught, would have a B, E, G. Which is actually kind of funny because that's what set C started as. So you almost got back to where you started in that situation. Okay, there is one more term that you have to grasp, and that is the Cartesian product. Okay, the Cartesian product is written as A cross B, and it's going to be the set of all possible ordered pairs. The first letter is going to be all the elements of A, and the second letter is going to be all the elements of B. And you want to try to come up with every single combination that you can. So when you do this, you're going to pick the first element of A, and you're going to pair it up with every element of B. Then you'll pick the second element of A, and you're going to pair it up with every element of B, and you're going to do that until you run out of possibilities. Okay? So for example, we'll just do one, A cross B. Let's say that set A is orange, banana, apple, and let's say that set B is 1, 2. Okay, if I want the Cartesian product A cross B, I'm going to start with orange, and I'm going to make all the pairings I can with orange. So my pairings are going to be orange 1, orange 2. Then I'm going to go to the next one, which is banana. And I'm going to have banana 1, banana 2. And then I'm going to go to my last one, which is apple. And I'm going to have apple 1, apple 2. And that's it. Once you've created the list, you have found the Cartesian product, A cross B. Okay, guys, start your homework. Let me know if you have questions.